Reserved words and identifiers. A scanner is almost done. The only remaining pieces of the lexical grammar to implement are identifiers and their close cousins, the reserved words. You might think we could match keywords like or in the same way we handle multiple character operators like less than or equal, like case, o code, colon, next line if parameter parameter of matches code or inside add token parameter or closing then break. So you might think we could match keywords like or in the same way we handle multiple character operations like less than or equal. Now consider what would happen if a user named a variable orchid. The scanner would see the first two letters or and immediately emit an OR keyword token. This gets us to an important principle called maximal match. When two lexical grammar rules can both match a chunk of code that the scanner is looking at, whichever one matches the most characters wins. So maximal match is that whoever has the most character wins. So we can't just match it with or, we need to look on all of the characters, not just the two characters, such as this example, the or. That rule states that if we can match orchid as an identifier and or as a keyword, then the former wins. This is also why we tactically assumed previously that less than or equal should be scanned as a single less than or equal token and not less than followed by equal. So this is the same reason why we use less than or equal instead of less than first and then interpret it as equal. Consider this nasty bit of code. Minus 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 a semicolon. Is it valid? That depends on how the scanner splits the lexemes. What if the scanner sees it like this? Minus, then space minus minus a semicolon. Then it could be parsed, but that would require the scanner to know about the grammatical structure of the surrounding code, which entangle things more than we want. Instead, the maximal match rule says that it is always scanned like minus minus, then space negative a or minus a semicolon. It scans it that way even though doing so leads to a syntax error later in the parser. So remember, the scanner only wants the smallest amount of sequence. It doesn't know yet the surrounding code. It doesn't make meaning with these lexemes. Okay, so it's still trying to create token from the smallest sequence. So it does this in dash 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 a semicolon. It does a dash dash space dash a semicolon, even though doing so leads to a syntax error later in the parser. Maximal match means we can easily detect a reserved word until we've reached the end of what might instead be an identifier. After all, a reserved word is an identifier. It's just one that has been claimed by the language for its own use. That's where the term reserved word comes from. So we begin by assuming any lexeme starting with a letter or underscore is an identifier. So for this example, in scan token, in scanner.java, we have default, right? Colon, and the next line if is digit parameter c character, and then inside is a number method, semicolon, then closing, then else if is alpha parameter c, then next inside is identifier method, semicolon, then else inside is locks.error parameter line, comma, quote unexpected character, closing. So note this is the same locks.error unexpected character, and then this is the same if is digit parameter c, then inside is a number method. We just insert this else if is alpha parameter c, then inside is an identifier method. So this is how it looks like. The rest of the code lives over here. So we create this helper after the scan token, private void identifier method, So notice that we use that, or we handle that case first on that our switch case, and then we created a helper here, private void identifier method. Then inside is while is alphanumeric parameter pick method, then advanced method. Then next time add token parameter identifier, then closing. So that's how we handle identifier. As you can see, inside this private helper, we use the pick and advance again. So we define that in terms of this helpers. So after that, after pick next, which here the pick next that we have earlier. Um, so notice is alphanumeric parameter C, then is alpha, which we created earlier. After the pick next, so that's before is alphanumeric, and then after pick next, we will add this private helper. Private boolean is alpha parameter C. The next line return parameter C is greater than or equal code A, and C is lesser than or equal parameter Z, or C, or open parenthesis C is greater than or equal code A, and C is lesser than or equal to code, or C equal code semicolon. The next line private boolean is alphanumeric parameter char C. Inside this return is alpha parameter C, or is digit parameter C, then closing. So this is after X. Next, that gets identifiers working. To handle keywords, we see if the identifiers text is one of the those reserved words. If so, we use a token type specific to that keyword. We define that set of reserved words in a map. So we create a map. So scanner, it's still in scanner.java. We add this in class scanner. So here, private static final map parameter string comma token type comma keywords semicolon. The next line static open, then inside this keywords equal new hash map, and then semicolon. Then next line keywords that put parameter n comma and semicolon. Next line keywords that put parameter class code comma class. Next line keywords that put parameter s comma else, and then the same with false, for, fun, if, nil, or, print, return, super, this, true, var, while. Then after we scan an identifier, we check to see if it matches anything in the map. So here, in identifier method, so while is alphanumeric parameter pick method and advanced. So after that, we add this string text equals source that substring parameter start comma current semicolon. Next line token type equal keywords that get parameter text semicolon. Next line if type equal null, then type equal identifier semicolon. Next line add token parameter type. So this is logs in identifier method. So we replace while 9. If so, we use that keyword's token type. Otherwise, it's a regular user-defined identifier. Now first, the lexical grammars of Python and Haskell are not regular. What does that mean, and why aren't they? Second, aside from separating tokens, distinguishing print foo from print foo spaces aren't used very much in most languages. However, in a couple of dark corners, a space does affect how code is parsed in CoffeeScript, Ruby, and the C preprocessor. Where and what effect does it have in each of those languages? Third, our scanner here, like most, discards comments and white space since those aren't needed by the parser. Why might you want to write a scanner that does not discard those? What would it be useful for? Fourth, add support for lock scanner for C style /*/ block comments. Make sure to handle new lines in them. Consider allowing them to nest in adding to support for nesting more work than you expected. Why?